changed my mind.
You should have went.
Yeah. Probably.
Definitely should have went. So, about 1:20 in the morning.
Right.
Joe, I would stop talking right there.
You know this game? I had him.
Yeah.
That was when I was hanging out with Kaylee the night before that. And then the next day, I went. He did the exact same thing. He was coming in, I swore waist, and he put her on a trail. He was 50 yards. He was within crossbow shot, but within brush. So I had to launch my bolt through brush. How's senior today, guys? Work on mag. It was amazing. I don't mind senior, mainly because I've got a bunch of morons.
Sorry you had to deal with that. Yeah.
Drive yourself.
And then like 10 minutes left to leave.
Get your notes out, please.
There were so many people in pre-cal, and now look at the cal class.
There were two pre-cal
There was
classes.
2 hours of pre-cal, and it just kind of
Yeah, and some are seniors.
slowly dwindled down to 1 hour.
What he meant like just this class and then just our time.
I'm just saying, I think it's funny the fact that like, you know,
I'm confused. Were you guys all in the same class or something? Really?
could be it. Probably. Most likely.
No, it's like half.
Yeah, that makes sense.
Alright, what you guys got on the score for the Tecumseh game?
Sheila, you want to do the easy ones here first, or the harder ones?
Harder ones.
Okay. What? Things get a little more real. So we got a product rule because we have a function of x times a function of x. But then when you go to take the derivative of either part of it, for like the d1 and the d2 parts, those are both chain rule. Also, we're going to get negative exponents. Oh wait, no negative exponents. One term. That's another rule for simplifying. We're going to get negative exponents, we're going to get 2 terms. We're going to get fraction exponents, and then we got to fix all that. This is like a lot of the other things. The calculus is not the hard part here. It becomes just like algebra on steroids.
Yeah.
Sheila, you take steroids, right?
Of course, can't you tell?
Right, yeah. Am I good to start going, or are people still writing? Alright.
You're good to go.
Okay. So, this is product and chain in the same problem. So you're going to need a lot of room. So I'm starting right off the left here. So, product rule is the main driver of this, and then within the product rule we have 2 chain rules. So the product rule says we write down the second thing, and we multiply by the derivative of the first thing. So that is 1/3 3x plus 4 to the negative 2/3 times what? Times 3, and it'd be really easy to forget that 3, especially as the problems get bigger and bigger. And they don't get much bigger than this. This is about as intense of an algebra problem as you'll get. But you do 3, 4, 5 steps, combining all this stuff, and you forgot that 3, like you're really going to be mad at yourself. So that's the second thing, and then that's the derivative of the first thing. Good there? Yeah.
I don't know how you went from the 2/3 or 2x minus 5 to the 3/5, and then why would you do the next step? I don't know.
That's product. This is my second thing. This is my first thing. So this is my 2, and this part here is my d1, like the derivative of the first piece. So this is the derivative of that.
Like product rule is big thing, little thing, right?
You're thinking of chain rule.
That's true.
Oh.
So chain rule is how I got from here to here.
Yeah,
But there's also product rule, which is like the first step, really. So I'm doing the second thing times the derivative of the first, and when I do the derivative of the first, that's when I need chain rule.
so second thing times the derivative of the first.
And then I'm going to do the first thing times the derivative of the second, but when I do derivative of the second, what am I going to need? I'm going to need chain again. So this is my 2d1, and then the first thing times the derivative of the second thing. So if I just said take the derivative of this piece here, you would need chain rule. So we're going to bring down the 3/5, leave Mr. Packard alone. We're going to reduce the power by 1, and then we're going to multiply by what? We're going to multiply by 2 because that's the derivative of the inside. So this is 2d1, and then this is 1d2. And that's the calculus. But now we got to do, you're not allowed to leave it anywhere close to that form. So we can't have negative exponents. And we have 2 terms right now because we got this giant plus sign. So it's this one term plus this other term. So we're going to get rid of negative exponents first. That's going to give us 2 fractions. Then we're going to get a common denominator for the 2 fractions and add those up so that we have 1 fraction. That's the grand plan. So, there's a lot of like whining. Do you guys want to take a second and like sigh and get your whining out? Like, take like 10 seconds and just complain. Go for it.
Why?
Jeez, oh jeez.
Yeah.
Are we good? Wow. All right.
What did you say?
Yeah, shut up.
I didn't sign up.
Signed
I
up for
signed
calculus.
this out loud.
Oh, sorry. For the house party.
Roll up my sleeve. Take my coat off. Alright. So, anything with a positive exponent goes on top. Anything with a negative exponent goes on top. We got this 1/3 here. It goes on the bottom. We got this 1/3 here. There's 2 things I can do to work with this. I could just be like, okay, that's my pre-established top and bottom, 1 on top, 3 on the bottom. But I also noticed that what am I going to do with this 1/3 and this 3? If I multiply them together, what's going to happen to them? They're just going to cancel. So I'm just going to cancel them now. And then this fraction over here becomes 2x minus 5 to the 3/5 over 3x plus 4 to the 2/3. Leave space before you put the plus sign, because we're going to have to put stuff there. Same thing with the other one. This one, these don't cancel, so I'm going to put 6/5 as my fraction. You can see where I'm getting the 6/5 from. 3/5 times 2. Those are the 2 numbers I have there, so 3/5 times 2 is 6/5, and then that establishes, okay, there's a 6 on top of the fraction, 5 on the bottom. This is a positive exponent. Positive exponents go on top. This other one has a negative exponent, so I flip it to the bottom, and it becomes positive. So that's the rewriting, so there's no negative exponent. So I did that. But I still have 2 terms. So I can't have 2 terms. Because the whole point of this is eventually I want to be able to say, set this equal to 0. And so if I told you to set it equal to 0, your first step, you're going to come denominator and add them up. So we're just doing that now. So we don't have to worry about it later. Okay. Your common denominator here. So if I had like 1/3 plus 1/4 plus 1/5. What would your common denominator be? It'd be 60. How can we get to that? We just multiply them all together, didn't we? And there might be a lower one. There's not in this case, but sometimes there might be a lower one. But multiplying them all together will always give you a common denominator. So if I had like 2 4s plus 3 8s, what's the actual lowest common denominator? 8. But could you use 32 and still be okay? Yeah. So if you're stuck, always just multiply. So we've got 3 things here on the bottom. This 3x plus 4 to the 2/3. We got a 5, and then this 2x minus 5 to the 2/5. Easiest thing to take care of, I think, first is just this 5. There's a 5 on the bottom on this side, so there better be a 5 on the bottom of that side also. But if I put a 5 on the bottom of that side, I better put a 5 on the top also. So what did I really just multiply this fraction by? 1. Didn't change it, didn't change the value of it, I'm just rewriting it so it fits in, it makes it easier for me to work. I'm going to need this 2x minus 5 to the 2/5 to be on the bottom over here. Right? So I just want to multiply all the bottom denominators together. So this one I need to have a 2x minus 5 to the 2/5. Well, watch what happens on top, and this always happens because of the way the rules work. If I put it on the bottom, where else do I have to put it? I have to put it on top. And you'll notice now, so I used to have 3/5 of them on top. I now have 2/5 more. How many do I have on top? I have 1. And that will always work out that way. Because the way it happened is you subtracted 1 from the power, and then when you put it back, these are just going to add up to 1. I shouldn't say never, but you won't usually get some weird fraction up here. Over here, what do I need? 3x plus 4 to the 2/3, which means I need it on top also, right? And notice again, I just put 2/3 more of them on top. I already had 1/3 on top, so how many do I really have? Just 1. So that makes the top easier to work with. Let me stop there. Why'd you do this? Where'd this come from? What in the F of X tenth?
Yeah, that's honestly what I'm thinking right now. What in the F of X happened?
Is there a specific spot I can...
No, it's just, I understand it, but I don't know how I understand it.
Alright, I
I'm
mean,
really going to tell you what I don't understand about it.
we'll practice them. I mean, that's fair. So we started with this on the bottom here, and we started with these 2 things on the bottom there. So I needed to put this 5 over there, so I put it top and bottom. I needed to put this 2x minus 5 guy over here, so I put it top and bottom. And I needed to put this 3x plus 4 thing over here, so I put it top and bottom. Now if I simplify, it should get a lot better. So on the top, what I really have is 5 times just 2x minus 5. Because I have 2x minus 5 to the first now, right? Because if you're multiplying the same base, you add up those powers. So now I just have it to the first. On the bottom, I have 5 times 3x plus 4 to the 2/3. Don't cancel those 5s, because if you do, what did you just ruin that we worked so hard to get? Common denominator. Cancel the 5s, you just ruined all that. Denominator is the same over there, and then on top I have 6 times just 3x plus 4 first. You with me? Just kind of. And then when your denominators are the same, you guys forget this. If I have like 2 7s plus 1 7, what's my answer? 3 7s, right? The 7 stays the same the whole time. 2 pieces out of 7 in a pie plus 1 more out of 7 in a pie. You had 3 of the 7 pieces. The 7 stays the same. So on the bottom, that denominator just stays, and it's common now. And on the top, I'm kind of running out of room. I am running out of room, so I'm going to shortcut this last step a little bit, but I'm just trying to simplify this top. So 5 times 2x minus 5, wouldn't that be 10x minus 25? And then over here, when I have 18x plus 24, I'm just distributing. So how many x's do I have altogether? 28x, and then minus 1. And then this is the form that I want the answer in, and then you could, if I forced you to, or asked you to, you could say, okay, set the top equal to 0, set the bottom equal to 0, work with this. We have one fraction, we have no negative exponents. That's the goal. And that's probably the toughest type problem that you'll, even in the next 2 days, that we'll do. Like product and chain, they don't get much worse than that. So we kind of started from the worst.
So wait,
Yeah.
is quotient and product or quotient and chain?
Quotient and chain is death, but you can avoid it. So, no, I'm serious. So, like, if you get, like, we'll get into this more in the next couple days, but let's say I have this. Quotient and chain together is awful, but you don't have to do it because you could rewrite it like this, and then do product and chain.
Oh, they tried to trick me.
Quotient and chain,
Are we gonna learn how to do it?
we are, I mean, it can come up, but mostly the way I'll teach you to do quotient and chain is to set it up so that it's no longer quotient and chain.
Figure out how to do
Yeah.
it. Is it really like that?
So what happens is you get these fractional exponents, and you'll have a fraction on top with fractional exponents, and a fraction on the bottom with fractional exponents. So you have a fraction over a fraction, and people's brains just explode. And it's, yeah. I mean, so if you had like a trig or something, we'll practice anything that'll be out there. I'm not gonna you'll never have to do this and then throw it on the test. Any questions in there that I can go through at all? All right. You try one.
Okay.
Okay.
Should we do one more together?
No. I want to start out there. I want to figure it out.
And these I could do this in radical form too. This could be square root of x squared minus 4. Just trying to save that stuff right now because it just becomes like annoying with all those steps we have to do after. So remember, you do a product rule, big picture, and then within the product rule, you're doing chain rule twice. So there's your first step. There's your calculus. I'll check that. This is the second thing. This is the derivative of the first thing. This is the first thing. The derivative of the second. And it becomes crazy algebra. Okay, so I'm going to rewrite everything. So this term, I'm going to look at as like a whole chunk. And I'm going to start flipping top and bottom. I see this 1/2 times 2x. So I'm just going to make that x on top. This 4x minus 7 to the 2/3 is a positive exponent, so that goes on top. And then the x squared minus 4 goes to the bottom, becomes a 1/2 power. You might have put like a 2x up here and a 2 down here. And then at this point you could cancel them, right? You just set up with the x, so it doesn't matter how you got there. You can actually even leave the 2 there, just make sure common denominator work a little bit tougher. Questions on what I did on this fraction here? Okay. Same idea over here. I'm going to do the 2/3 times the 4, and that's 8/3. So that kind of sets up, okay, you're going to have an 8 on top and 3 on the bottom. That's a positive exponent, so it goes on the top. That's a negative exponent, so it goes on the bottom. And then the same idea as last time. We have 3 things on the bottom. The common denominator is just a multiple. Those 3 things multiplied together. So the easiest thing to start with, I think, is the 3. So I need a 3 here, which means I need a 3 here. I'm also going to need this 4x minus 7 to the 1/3 over here, which means I need it on top. And a good check that you're on the right path is these 2 powers should add up to 1. So that I feel like I'm doing well so far. Very proud of myself. Then I need this x squared minus 4 to the 1/2 over here, which means I need it on top also. And again, I notice that these 2 add up to 1, so I feel like I'm on the right track. Questions on that step? I feel like you have that step correct. Okay. So then, on the bottom over here, I have 3 x squared minus 4 to the 1/2, and the 4x minus 7 to the 1/3. On top, I have 3x times, don't I just have times 4x minus 7? This is the first power now. Same thing over there. Just rewriting the bottom. And then I have 8 times x squared minus 4 because there's only one of those. Questions there? So I don't have room to write this step out a second ago. I'm going to write it out this time just for the sake of being complete. It doesn't matter to me if you write it or not. But I'm just doing the distributive property here and the distributive property over there. And I'll combine them all in a second. I don't know if this step is necessary for you or not. That's for you to decide. But I end up with 20x squared minus 21x minus 32 on top. How many of that? Nice. And then your bottom is, that jumbled mess that you still have down there. But the point is now, if I set the top equal to 0, you can do it. Set the bottom equal to 0, you can do it. And we could move forward from there. Yeah.
I don't know what I did. On the top, I got 40x squared minus 7x minus 64. They're all alternatives. I don't know how I did this.
I almost got an index, or I got minus 42, but I kept the 2's, and then so I just got like double the number. What you got?
So that's an important, let me bring that up. You might have 40x squared minus 42x minus 64 over 6 times this stuff. Brooke, is that what you're saying?
Yeah.
So this is also an acceptable answer. So if you didn't cancel those 2's like I did way back here, the 1/2 and the 2, if you didn't cancel that, this is what you would end up with. It's the same answer. So notice all I did to get from here to here would be how many. We should check this. How many terms are in this answer right here? How many terms are there? That is one term. How many terms are within that term?
Oh.
4. So if I divide all 4 of those terms by 2, don't I end up with that same thing? And that's so it's the same answer. Do you see what you did?
Yeah. So I did what Brooke did.
Okay.
Where I got that answer, but I didn't multiply the 6 and the 7 to get the 42. I just
So you just left it at, okay,
Yeah,
gotcha.
I just left it, and I was like,
Okay.
oh man.
So it felt like you were really far off, but you weren't.
Oh,
It was just
yeah,
like one little. Matt, you got a question?
Yeah. You go up a little. How did you get the 3x?
This?
Yeah.
Well, it was just an x because I did 1/2 times 2x. So half of 2x is x. And then there was a 3 on this denominator, but not on this one. So then I put a 3 down here, and I had to put a 3 up there to balance
I
it.
see.
Is that right?
2x. Yeah.
Yeah. You good? What else? Alright. Let me show you the other kind of problem that will come up, where it's not fractional exponents and it's not negatives. So these are a little friendlier, I think. Because I asked you what you want to start with, these are the hard ones.
Yep. Another one.
Same rules, no negative exponents, but that won't come up here. There won't be any negative exponents. And one term.
Just easier or hard?
I think it's easier for most people. So it's still product and chain, right? I still have a function of x and a function of x, and they're being multiplied together. So the big picture is product. And then when I do the D1 and the D2 part, those little sections become chain. So the second thing is x squared minus 4 to the 4th. The derivative of the first thing is bring down the 3, leave the 5x plus 4 alone, reduce the power by 1, and don't forget to multiply by the 5. It's going to happen so many times. You do this 6-step problem, and you got common denominators, and you're factoring, you do everything right, except you forgot to do the chain. On the gateway, you get the whole question wrong, right? Because it's all right or all wrong on that gateway. So just be really careful. Be diligent about your steps, I guess. So this is my 2 and my D1. Then plus 1 times D2. So the derivative of the second piece is bring down the 4. Leave the little guy alone. Reduce the power by 1. And then again, don't forget the chain rule piece. So multiply by 2x. How many terms do I have? 2, so that's the problem, so we have to fix. Well, let's check that step. Are we good there? See where I'm getting what I'm getting? We all set in that first step? So now I just need to do reverse distribute. I'm going to factor. And I'm looking for big chunks that I can take out. So, for example, there's an x squared minus 4 to the 4th in this term. There's an x squared minus 4 to the 3rd in this term. So how many of them can I take out? 3 of them. So I'm going to take out an x squared minus 4 to the 3rd, which means I'm essentially dividing this by x squared minus 4 to the 3rd. And dividing this by x squared minus 4 to the 3rd. Well, there's another chunk. So you might want to wait until I'm done almost, and then see what I'm doing, because it might not make sense right now. How many 5x plus 4s can I take out? 2 of them, because I got 2 there and 3 there. So I'm going to have that, and then the inside, I'm going to write what is left after I divide by the things that I just took out. So it's going to become like a distributive property looking thing. We're doing it in reverse. Do we see where I got why I chose 3 of the x squared minus 4s? 2 of the 5x plus 4s? Okay. So when you distribute, you're multiplying, right? You know, like what's 6x times x plus 2? 6x squared plus 12x. You multiply to do that. So when you're reverse distributive, you're reversing the multiplication. You're dividing. So I need to divide by the stuff that I just took out. Well, if I look at this term, how many x squared minus 4s will be left over? Just 1, because I got 4, and then 3 of them would go away. This 3 is still there. How many 5x plus 4s are there? None, because they both cancel. And then the 5 is still there. So the whole point of this is if I distributed, if I did this times this, I would end up with what's up there. I'm just doing it backwards. Yeah.
So on the last one, can you just re-explain your steps on how you get all of the numbers on the bottom equation? On the bottom?
Like right here?
Yeah. No, like all of them.
Everything?
Yeah.
So first I'm looking to see how many chunks can I take out. So I see x squared minus 4 to the 4th here and to the 3rd here. That means I can grab 3 of them and pull them out in front.
Yeah.
I couldn't grab 4 because I can't take 4 from 3. You know.
Yeah.
Same thing with the 5x plus 4s. There's 3 there, there's 2 there, so I can take 2 of them and yank them out in front. So this is where I got what's out here. And then I'm going to divide both of the big fractions by what I just took out and write down what remains. So if I do that same process over here, x squared minus 4 to the 3rd, how many of those are left? They're all gone, aren't they? 3 on the bottom, 3 on the top. Alright, how many 5x plus 4s are left? 1. We have 2 in the bottom, 1 on top now, so 5x plus 4. And then what else is left? Times 4 and times 2x.
Okay.
So now it's distributive property. So if I did this times that, and this times that, I'd end up with where I started in that previous step, right? And your job now is just to clean up the inside. So you're just like distributing and multiplying and adding. Like from there, it's pretty easy. So I'd have like 15x squared minus 60 plus, because this is really 15, right? This is really 8x. 40x squared plus 32x. We're not quite done, but how many terms do we have now? We have one. So the point is, if I ask you to set this equal to 0, you would know what to do. You would take each of these pieces and set them separately equal to 0. So I end up with 55x squared plus 32x minus 16. If I set that equal to 0, now you got, okay, I'm going to set that piece equal to 0, that piece equal to 0, and that piece equal to 0, and I can solve those all separately. That's the reason we're getting it all into one term. I didn't ask you to set it equal to 0 yet, but if and when I do. Questions on that one? It's not a question.
Can I take it?
No. Try that fella. Thanks. I was trying to throw it away there, miss. No. It didn't sound like you wanted it.
I told her to just throw them away, and she's like, I can't do that. That's mail.
I mean,
I know.
I understand that. Do you want me to throw it? So we're going to check this in a minute. I'll go through it. Your homework is just the odds on this sheet. There's 10 problems. So your homework's 5. Don't forget you got con due Friday. So this is another thing we learned that you were not able to do on con. That you could. Keep in mind the giggling while you're doing these. This is what'll be on there. All 10 won't be this long, but there'll be a couple of them. You know, probably one of each of the kinds that we went through today will be on there. We're getting close-ish to. I'd say it'll be next week. first step. Here's your first. The derivative of the second. Second. And the derivative of the first. Can you check that first step for me and just raise your hand if you got the first step right? I'm trying to figure out if there are mistakes, if they're in the calculus or the part after that. Okay, cool. Yeah,
Oh no, I got it right. It's just good film.
the moment it kind of passed though,
Yeah.
but I appreciate your feedback.
Just make sure.
Yeah. Alright, so I'm looking at my chunks, right? So this, if I have parentheses to a power, that's kind of my clue. How many 2x plus 5s can I take out in front? 2 of them. How many x squared minus 3s? 4 of them. And when I do it, I don't write the division part. You can if that helps you, but to me, I'm just going through and like, okay, I used to have 3 of these, I took 2 out in front, well now there's only 1 left. I used to have 4 of these, I took 4 out in front, well now there's none of them left. And then I just write down what's left over. So that might be easier. I was showing the division so you can kind of see what really happens, but I don't know if you need to write that every time. Then I'm going to take the 5 times 2x and just make it a 10x right now, because that'll make my next step a little simpler. Same idea on this other term. Well, I used to have 5 of these in this term, and I took 4 of them out front. So now there's 1 left. I used to have 2 of these, and I took them both out front. So now they're all gone. And then what I have left is the x squared minus 3, and I'm going to combine the 3 times 2 and just put a 6 there. And from here, it's like algebra 1. So at least we're past the steroid algebra part. So now you're just distributing and adding up the like terms. Not that you might not screw it up. I mean, I could easily screw it up. You could easily screw it up. But at least I think the hard part is done. So this will be 20x squared plus 50x. This would be 6x squared minus 18. So I'd end up with 26x squared plus 50x minus 18. How many agree with that answer? And then if I said set equals 0, we could do that. Questions out of anywhere. I don't know where you got this from, what you do here. Go through this again.
Yeah.
Alright, we made it 7 seconds. So do the odds for homework, please. And then bring any questions on those tomorrow. Because they probably set them up a little different than I do. You know, so there might be little tweaks that show up in those problems that you haven't seen. We want to get those answered. And then we'll probably just do the evens in class. So just practice them more. Because these take some practice, I think. On Wednesday, we'll move on to something. Probably do quotient and chain, which, like I said, is really just product and chain again. And then, I start bringing trig and e's into this
I
ball game.
feel like I'm gonna regret saying this, but I feel like trig would be a little easier. Be a little more neater. In the fact that
just
we're not
simplifying.
using letters that we're using, or we're not using numbers, we're using letters, so we don't.
Simplifying's easier.
Yeah. Just feel like I've already done a question on this.
Okay. Let me stop my video here.
This is You ready for senior night?